Peter. Good morning, everybody. I'm very pleased to talk in front of an audience who are so well informed on this subject. My presentation is about a very small TETRA system that we have installed in our Reliance refinery complex in Jamnagar in India. The agenda includes a short introduction to Reliance, telecommunication usage at Reliance refinery, choosing the technology, why TETRA was chosen, and then the way forward. Introduction to Reliance. Reliance is present in all the three streams of activities in the oil and gas operation. We are present in the upstream. We have got 4 major companies within the upstream. Reliance KG Basin, which is a deep water gas exploration. It's in the east coast of India. Reliance BP with British Petroleum, we have a joint venture. And this is also involved in, this venture is also involved in the deep sea oil and gas exploration. So mostly gas and a little bit of oil in this. Then we have Reliance Shale Gas. Shale gas operation is all in the US. We own some properties in the US, and it's all in the US. It's nothing in India at the moment. And Reliance Coal Bed Methane is a small operation compared to the other 3, and it's in India, somewhere in the central part of India. We're also in the midstream. We have Reliance East-West Pipeline. It's about 1,470 kilometers of 48-inch pipeline running from East Coast to West Coast, carrying the gas from the Reliance KG Basin all the way to the West Coast. We have Reliance LNG terminals. We have 1 terminal in India. We have 2 terminals in the East Coast of Africa and 1 terminal in the US. Then in the downstream, we are in a lot of petrochemical activities. We produce a lot of polyester, staple fiber, filament yarn, polypropylene, PVC, LDP, HDP, a whole lot of polymer business we are into. And we have a very large refinery. We have, in fact, 2 refineries come up in 2 different stages, located in 1 location. It happens to be perhaps one of the biggest refinery in the world in single location. It's about 66 million tons per annum capacity. And we are also in the other business. Reliance is into retail. Reliance is into life science, which is largely a research organization. And we are also into textiles, though it's a small operation. Reliance was founded by one Mr. Dhirubhai Ambani. Way back in 1980, this whole operation started, and there was no looking back after that. We have become such a big company. As of last year's turnover, we are about in excess of 58 billion company now. This group, and it happens to be the largest private sector company in India. And we are we are one of the few Indian companies listed in the Fortune 500 list. Typical oil and gas operation activities includes all these 4 distinct operations: exploration, development, drilling and extraction, production, transportation, refining, storage, and distribution. We are present in all these 4 activities, but we are rather small in the last activity, which is the consumption, the direct retailing of petrol. We don't do much of that in India because of these 2 refineries. One of them is a 100% export-oriented refinery. We export almost the entire output of one of the refinery. It's located in the special economic zone. Complete oil and gas communication solution. These are the requirements that any communication solution in oil and gas industry. It has to be flexible and scalable. It has to be flexible enough to meet the upstream, midstream, downstream communication. There are slightly different applications, different requirements in these 3 streams. And it has to be therefore flexible. It has to be scalable. So as we grow the business, we don't want to end up with a system which is all standalone and then interconnect them. Instead of that, it has to have a seamless scalability. That's what we are looking for. Efficient communication, group call capabilities to talk between a lot of groups. And it should be always available, very reliable system, 24/7. Then it should also have voice and data integrated into one system so that we can monitor wellheads, reservoir, pipeline monitoring. All this will become possible as we go along, and even do location tracking, vehicle location tracking. Then we need to have very intrinsic safe devices. It should support, the system should support intrinsic safe devices for suitable in hazardous working environment. And finally, it has to be cost effective in the sense it should be a simple system relatively to be maintained by in-house engineers, not looking if something goes wrong. We should be able to have our own engineers go and fix it up in the shortest possible time. Therefore, it should be quite intuitive and simple to that extent. For efficient voice communication, these are the basic requirements. Group calls with the fast call setup, which TETRA offers. Should be able to talk between a lot of groups. And there should be also individual calls sometimes is required, like GSM 1-to-1 calls, full duplex is also required. And it also requires telephone calls to the EPBX and cellular phone at times. There are people who don't have, there are some people who may not have TETRA terminal, but they may be required to contact the target groups in TETRA. So therefore, it should have, the system should have interoperability with the other system, should be integratable with other telephone systems. Emergency call by a press of button should preempt all other calls, and the emergency call should go through. Priority calls with good call queuing features is needed, and calls between the groups for announcements. A typical radio communication in refinery happens in a 3 to 5 kilometer radius, and mostly we use VHF analog radios dating back to 90s technology. Radio communication used between various groups, and then radio communication between refinery control room, plant control room, and plant on-field teams. We have a very large control room. It's a single control room, is almost as big as this room. And we have small satellite control rooms in some of the plants. And we also have this plant on-field teams. The technicians and the operation team is all located in a small kiosk closer to the plant so they can respond faster in needs of emergencies. So there's constant communication between these three groups taking place all the time. And radio communication is also used for our jetty. We have a small jetty, a port, and therefore when the ships come to load and unload, there's a lot of communication that goes on between the control room and the plant operation team and the jetty people. Getting started. In 2008, Reliance had ventured into migrating towards digital trunk radio system from the traditional analog radios that we were using. One of the major reason was that as we expanded, we were wanting more and more frequencies, and government was not encouraging us to use more frequencies. They were very reluctant to give us more frequencies, and we have already used up, I think, as many as 26 spots of frequency license we already were holding. So they were very reluctant, so we thought the only way to do it is to go for digital trunk radio system. That was one of the major reasons. And we selected 5 operating plants, manufacturing sites. These are those 5 sites, wherein we decided we'll migrate to TETRA, digital trunk radio. And at the end of the plan, we are likely to have about 13 base stations with about 3,500 terminals spread across about these operating plants are about 600 kilometers from each other. It's all in the western coast of India. So selection of technology. After careful review, Reliance selected TETRA. We looked very seriously at TAPCO and other technologies, but somehow we selected TETRA because somehow we felt it's got a lot of advantages for the rest of it. Relatively, it's got advantage, some good spectral efficiency compared to other trunk radio system. TETRA is an open standard, proposed by none other than ETSI. It's not a very closed proprietary standard. It's proposed by ETSI. So that gives a lot of confidence that we are, going for the right technology. It's got interoperability to an extent. I wouldn't say TETRA is fully interoperable, but at least the terminal, at least moving towards that. The standard is trying to move towards a higher degree of interoperability. at the moment, at least the handset, the mobile radio is interoperable. So once you go select a vendor, you don't have to get tied to the vendor for the whole lot of things. There are people who are developing applications. There are a lot of handset manufacturers. You can pick and choose the best radio terminals of your choice. This is one of the reasons why we felt TETRA was more suitable for our kind of this application. And it's available in 380 to 400 megahertz. That's a frequency that the private user in India is allotted by government. So it is available in that. That was another point. And then it's an evolving standard. Therefore, to a large extent, it's future-proof. We heard of TETRA 1, we know TETRA 2, TETs. Now there's going to be LTE TETRA, we are talking of TCCA. So it's evolving, since it's not a dead-end technology. It's going to evolve, and you're going to get all the benefits that as it evolves. So we'll be able to upgrade our system and go along with the tide and get the benefit of the evolution. There are a lot of other advantages we found. See, it uses latest Ethernet IP technology with the software switching matrix. It's got multiple. The second point was very useful to us. It's, when the base stations are spread over several kilometers and you have to connect it to a common MSO, that's the main exchange. You've got a lot of options. It doesn't tie you up with just E1 or a T1 or a lease line. You can use Ethernet, you can use IP MPLS, you can optimize the cost of your capex costs. So it's got a lot of options. This was one of the attraction we found, that it's quite the interconnectivity is not tied to one choice. It's got plenty of choice. Fast call setup time. It's got queuing capabilities so that you can preempt calls and have the more priority calls going through. It has got voice and data capabilities in the same system. And patching to this is very important, because when we migrate, we know that we can't migrate in just one day. It will take several weeks and almost a year it has taken when we migrated from analog to digital. So there will be a lot of analog stations still being used by others who are not in the core team of the activities, but we need to talk to them also. So it has to have a facility to patch up with the conventional analog radios and the PABX systems as well. Scope of work was like this. The first phase consisted of 3 base stations with 1140 terminals. This was all installed in 2008 and it's operational till date. We're quite happy with the system. The entire migration was very smooth. Initially there were a lot of apprehension that digital trunking radio push to talk, though we saw a lot of demo. I didn't know how the operators, we had some apprehension operators how they will take it, but it went on very smoothly. Then phase 1, in phase 2, we are going to have 3 more base stations and add 1,000 more radios, and other installations are in planning stages. In those other 5 locations, the other 4 locations of the 5 are in planning stage. This is the Google map of the installation. These are those 3 towers which have been commissioned already. These are those 3. And these are the 3 ones which have been erected. The towers are all up and erected. The electronics have been ordered. They have reached the site, but they've been installed but not commissioned because we are waiting for the frequency allocation. There's one here is going to cover. There's a port also. It's not visible in this picture. You'll see it in the next slide. This is the marine tank farm, what you see here. And over that is the port. So this is the marine tank farm. This is the marine tank farm. This is a 51-meter tower here. This covers a small port that we have here, port of call, and it's got single-point moorings there. These are for those large tankers. They can't come to the shallow waters. They can't come towards the port. So they all stop there, and there's a lot of submarine pipelines there. And it comes to the field pumping stations. So this, the one which is going to be put up near the marine tank farm is going to cover the port as well. And you see the labels, not used, one here as well, here and here. These are all those which have been erected but not commissioned. That's what it says, not used yet, but they'll be commissioned by 3rd quarter of this year. So phase 1 consists of mobile switching office, which is the main exchange. It consists of all this, what is written here: zone controller, network management system, switching components in redundant configuration, telephone internet gateways, short data router, packet data router, conventional gateway. It's a highly redundant system. It's got dual power supply. It's got dual feeders from two UPS, two independent UPS, and it's got an autonomous power for 6 hours of operation. So even if you have a big disaster in the refinery, TETRA system will still be working for 6 more hours after that. So it's fully redundant. And we've got a control center, dispatch console, and network management terminal. It consists of 3 base stations. We have used 12 carriers, 4 carriers per base station, and therefore you get about 48 channels. 3 are used for control, of course, for 3 base stations, and you get effectively about 45 channels for voice and data. Redundant site controllers. Site controllers again are redundant, and we have used even diverse antenna, dual diversity antenna. So it's all the way redundant. So we got about 1100 subscriber radios, different types, fixed stations for the console operators, 20 mobile ones for the vehicles, the ambulance and the other vehicles, patrolling vehicles, and about 1,000 of handle radios. Some of them are ATEX for critical operations in hazardous zones, and these are the targeted users. Yeah, when we started this project, we ran into a small surprise, because the main control room, which is as big as this, is quite big actually, because everything has been put in one place. It's got a huge video wall all over, and you can see the entire thing can be projected to the video walls. It's a blast-proof concrete building with very thick concrete. There's no, the coverage inside, it couldn't get into the building. So we looked at several options, including leaky wire, then trying to put some repeaters. Then finally we decided to move one of the base stations inside the control room itself. It's a bit of a overkill. We thought it's over design, but we want to be a little sure, because it's some new system for us. We were not sure how during emergencies the response will be, because everybody will try to panic and keep trying to talk, and maybe some of the control room operators may not get a chance to talk. They may not get the slot to talk. That was our apprehension, So we said, why not we move one dedicatedly inside the control room itself. We installed one inside, so that the control room operators always get a slot to talk to. And this station was not available for outsiders, because this radio waves cannot go penetrate the building. A bit of a over design, but it was more safe design, we felt, and it works very well. And this is the drawing of the antenna system in the ground floor. We have put the base station there. We have used attenuators. We have toned down the power to 5 watts. It's about 25 watts in the other 2 stations which are erected outside the building. The one inside the building, we have toned down the power to 5. Even with this large room, we were able to get, with all the attenuators used, as you see there, all these attenuators, 20 dB attenuators, we are getting about 48, very strong signal. In fact, minus 48 to 68 in most of the places, even in the corners, pretty strong signal. So this is the system architecture. It's all in there in one system. MOSO consists of all those things what we talked about, and those 3 base stations are covered by fiber network, and it's not shown in here. It's in a ring topology, so that even if they cut in one direction, it can continue in the other direction, and that is what it is. The whole system looks like. And the 3 base stations, redundant site controllers, dual diversity antenna. This is for the phase 2. I'm talking we're going to add 3 more base stations, exactly similar kind of a system with all redundancies, about 1,000 more subscriber radios. And targeted users this time is going to involve fire service, security service, medical service. You'll find after phase 2, all the entire refinery operation will get onto TETRA. This is one of the GUIs available we have a Motorola system in fact, and this is one of the several useful GUIs which are used. It's got all these features built in. You can dynamically do that, manually also do, or event-driven. You can do the broadcast, multi-agency, super call group. You can regroup them. You can do all sorts of things from the console itself. And this is another useful feature. And the one down below tells you, who is talking to whom, kind of what talk group is talking to whom, then current status of affiliation, to which tower it is affiliated at any given time. So useful to find out any congestion if possible is there. This is another snapshot. I'm sorry, I'm short of time. Let me run through. So this is a snapshot where you find those 3 base stations. There's one interesting thing, the one in the center, this one, though there are only 40, we have only issued 60 radios to the control room operator. There are only that many operators, but at any given time, 40 people are talking. That means TETRA is being used very effectively. People are all the time talking to there's a need for the communication with the various groups. That's why 40 out of 60 people are using in the base station, which is inside the control room. This is another one which tells about number of calls that goes through. You see, we picked, this is 1,000. We'll have to multiply the y-axis with 1,000. So it is about 37,000 calls. Some days, again, peak to 35. Another day, it's peak to 33 again. So there are plenty of calls going on every day, very effectively being used. And the one in the yellow is the PBX calls. Seldom it goes through. Of course, because of the scale, you don't see them. There are quite a lot of calls goes through whenever there's peak, when they're probably during the upset. You find along with the blue line, the yellow line has also moved up a bit. And the one in the green is the analog patch. There are not many calls go through normally, but we have a drill every month, one day. On that day, you see calls have peak. Just to ensure that system works, so there's a one-day drill a month to ensure that the analog system always works with the TETRA. So that's the reason why on one particular day, a lot of calls have gone through. And way forward, fine, we are going to cover this old refinery that's already on. This is the phase 2. By third quarter of this month, by this year, we will be completing the old refinery. So both the refinery will be on TETRA. Then we are planning to extend it to other manufacturing sites, as I told you, and explore possibility to extend TETRA to the offshore platform here. And we are thinking of use TETRA for data acquisition from field devices, sensors, handheld terminals. We have tried some handheld terminals, some field trials are going on. We have got some RTUs. We are trying to see how to use them. So very soon we'll be using this. Thank you for your patient hearing. Thank you. If there are any questions, please. I'm sorry about over in the time.
No, that's fine. Thank you very much.
Okay.
Yeah, thank you very much.